Welcome to day 4 of rational functions. So today we're going to be working, whoops, that was a little crazy. We're going to be working on multiplying rationals and dividing rationals. And so we've talked a little bit about rational numbers, right? And rational functions and rational expressions. Remember, a rational number is just a number divided by a number that doesn't end up as like a whole number. Like 6 divided by 3 would be 2. And so we have some examples of rational functions. We have one, our rational function, right? It's just a function divided by a function. And then we have some rational expressions, which would go down here. And this was basically all the things we did the first half of this. So what we're going to be doing today is we're going to start off, but we're going to multiply rational expressions together, and then we're going to divide. And kind of like always, right? Our first step is we're going to factor. And if you forget to factor these things, these problems are going to be much, much more difficult, if not impossible. So the first step is we're going to factor, and then we're going to simplify. It's almost as if we're looking for a whole. So let's start with example 1a. Let me turn this off, and then let me zoom in a little bit. So we can kind of think about this, right? Like just taking a look at this, and we're going to go down. The 14 we can write as 7 times 2 times a. So and you don't have to factor it like this every time, but it kind of is going to make sense because we could do 14 times 3 and we could do 15 times 8. But if we factor these things, 15 factors is 3 by 5, and then our 3 is just 3. And we could do 8 as 2 times 2 times 2, and then don't forget that a. If we factor these things to start off with, it's going to make our life a little bit easier because remember, if we have something on top and something on the bottom, think about like when we were looking at our holes, right? Finding those holes for last class. Those two things are going to reduce, right? If we have an identical factor on the bottom and an identical factor on the top, they're going to just simplify down and we're not going to have anything left, right? It's going to reduce. 3 divided by 3 is 1, 2 divided by 2 is 1, and a divided by a is 1. And so we're just looking at this with whatever we're left with on top and the bottom. So now when we multiply, remember we multiply straight across the top and straight across the bottom. So across the top we have just a 7, and on the bottom we have a 5 times 2 times 2. So 7 over 20. And that's our final answer. And that's it for example 1. So factor, reduce, multiply numerator by numerator, that just means across the top, denominator by denominator across the bottom. And the last step is simplify, right? So say that instead of 7, we were left with a 4 on top, then we would reduce 4 over 20, but that's all we can do. Looking at example 2, what we're going to do is instead of writing everything out like this and reducing, we're going to think about like what's on top and what's on bottom. And we're going to use a lot of exponent properties here for these things, right? Remember, if we have x to the m times x to the n, right? So the bases are the same. The exponents add together. And if we're dividing x to the m over x to the n, this becomes x to the m minus n. We're going to subtract those exponents because we don't want to like get into a problem like this example 2 and have to write out like 8 times x times y times y. That is not going to be super efficient. And so we want to try and do this a little bit faster, a little bit easier, and use our knowledge of geometry or use our knowledge of exponent properties to simplify these things. So think about, like, we've got this 8, and we have that 16. And so we can reduce those, right? Even though it's multiplication, or even because it is multiplication, we can just rewrite this, right? 8 over 16. I'm going to put a fractional bar in. 8 goes into 8 one time. 8 goes into 16 two times. And so we've simplified that. And I'm kind of looking around and seeing what else. And I like to start with the numbers, right? Start with numbers. And so I've got that 21 on the bottom, which I can't do anything with that 21. It doesn't look like. So I'm going to bring the 21 over, and it's going to be 2 times 21. And then let's talk about maybe our variables. And on the top, I've got that y squared, and I've got a y cubed on the bottom. And so we're going to use that quotient property, right? And if we are taking y squared divided by y cubed, that would be, and I'm going to write it out, it would be y to the 2 minus 3. And so there we go. And then, so that takes care of the y's. Let me highlight them so we don't go back to them. The y's have been taken care of. The 21 has been taken care of. The last thing we have is the x's. And so using that same quotient rule, this x on top is x to the power of 1, and that's divided by x cubed, so we're subtracting 3. And so we've taken care of everything, right? We've simplified. We need to do a little bit of rewriting. I'm not going to write this 1 again. So what we get is y to the 2 minus 3 would be y to the negative 1 times x to the 1 minus 3 is negative 2, and that's all over 42. And so at that point, we do want to take care of these negative exponents, and we're going to move them across the fractional bar and make them positive. So I'm going to do 42. And then we're going to do y to the power of positive 1 and x to the power of positive 2, and that's it. So problem number 2 is done, and that is it. So I want you to pause the video, and I want you to try and factor this problem before we get started. If you don't factor these problems, they're going to become, as we say in math, like they're going to be intractable, or they're going to be like interesting. It's going to be a really difficult problem to solve. And so we want to try and always factor that if we're able to, and that'll make life a little bit better. So pause, factor, and then come back in. And I'll go ahead and factor this while you guys are gone. Okay, so I factored it. I highlighted this 3x minus 9, right? And so what's happening is we're using that. We want to factor that as well. That's just greatest common factor. And then for our top function, you can see the factors. And if you're still struggling with factoring, you're going to have to probably start watching videos or doing something. So let's see what common terms we have. Like that number reduces, right? We got a 3 on top and a 3 on bottom, so it reduces. And, you know, even though it's written out like this, it's the same thing as if we were to close this line, right? And then we're just rearranging so it's 3 over 3. But instead of like doing all of that rearranging, we're just going to simplify. Basically, if we have the same thing on top and the same thing on the bottom, we know that's going to simplify. It's going to reduce really to about to 1. And so it looks like that goes away. So it looks like we're left with, on top, I've got a 4, and I have that x plus 3. And on bottom, I have an x minus 3. And you might be thinking, oh, x plus 3 divided by x minus 3. That doesn't reduce. We're just stuck with whatever that is. We can't do anything else. Okay. I want you to try and factor this problem. I'll give you a hint. This is a difference of 2 squares. And then I'm going to pause the video and I'm going to factor it out. And so, but I want you to try and work your way through it and figure out where all the pieces come from, and then check my work. All right, there you go. So if in case you're curious as to where this x came from, this x came from the x to the 5th. So we have that x to the 5th. Ooh, that wasn't the one I wanted. We have that x to the 5th and that x to the 4th. And so x to the 5th divided by x to the 4th would be x to the power of 1. And so this is our final answer. All right, now that we have done multiplication, let's go to the back and do division. And so all of these things on the back page are called, like all of these things are complex fractions. So basically we have a fraction over a fraction, like c could be c divided by 1. And so it's c divided by 6 divided by 5d. And so these problems start to become a little bit complicated. And the thing that I really want you to remember is even like this x minus 3 divided by 8 divided by x minus 2 divided by x plus 4, these problems are going to be really pretty simple. And you've done stuff like this before, you just don't remember it. And so, and you already know how to do most of this work. So you already know how to do most of this work. And our steps are, I don't necessarily love the verbiage. We're going to flip the divisor, and then we're going to factor. And so what you guys probably learned was, whoops, that wasn't what I wanted. What you guys probably learned is like keep, change, flip, or something along those lines. And here's what that means. So keep, change, flip. The first fraction doesn't change at all. So we're going to take a squared minus b squared over 4a. So that's our keep portion of this. The change is we're going to change this division symbol into a multiplication symbol. And the flip is we're going to take this fraction and we're going to write it, we'll flip it upside down. So 2a over a plus b. So keep, change, flip. Really what we're doing, and you heard me say these types of things, is we're multiplying by the reciprocal. So keep, change, flip is a way for you to remember how to do it. But what we're really doing is we're multiplying by the reciprocal. And at this point, you know how to do this problem. And so I'm going to pause the video, and I want you to pause the video and give this a shot on your own. I will tell you that piece right there, that a squared minus b squared, is a difference of two squares. So work on the problem and then unpause the video and see if you can do it, or see if you got the right answer. No.